let's consider another way to measure angles called radians. Let's consider some circle with radius r centered at the origin. And imagine that we are a little bug and we're going to start walking where the circle intersects the positive x-axis. Now, if I start walking and I walk for a length of r, I end up maybe about here. Now, if I draw in an angle whose vertex is at the origin, initial side along the positive x-axis, so we're in standard position, and then the terminal side is going to cut right through where our path stops on the circle. So I can see that my angle is opening up and kind of cutting off an arc length that has a length of the radius, so 1 radius. I'm going to call this angle theta, and I can say that theta has the measurement of 1 radian. So what I'm doing is kind of thinking about how big of a path or how long of a path am I cutting off by this angle on this particular circle. Let's try it again. So let's say I have my initial side of my angle here on the positive x-axis, and let's say I have my terminal side on the negative x-axis. I still have this same radius r, but if I want to know how big is that angle in radians, I want to know how many radii or radius measurements can fit along that path. So let's say we draw one here, and we draw another one, maybe about there, and then another one might fit about there, okay, and then we'd have, say, a little bit left over. This angle, let's say we call beta, and we'll say beta has a measurement. Well, how many radii can I fit in there? Well, it looks like 1 along the path. I walk 1 radius length, a second radius length, 1 radius length, a second radius length, a third radius length, plus a little bit more. So I'm going to say that that's maybe, I'm going to guess, maybe about 3.2 radians. So how is this system working? So let's look at it in general. So for some angle in general, we'll just use theta. How can I determine its radian measurement? Well, I'm going to look at the arc length that the angle cuts off. So let's look at the arc lengths that we just used. So with theta in this first picture, it cut off the arc length r. In this second one, this was the entire path that it cut off here, and we determined it to be about maybe 1, 2, 3, and a little bit more radii that would fit along that path. So in this case, the path, or the length of the path, is that S here that the angle cuts off. And then, but what we're doing is trying to see how many radii measurements are going to fit along that path. So how many radii lengths can I walk before I'm done with the path? Well, if I'm trying to think about how many times something fits into something, that is division. So it gives us this equation here. Now, if I wanted to figure out how many radians is 1 full rotation, so what would that measurement be? Well, I know that in degrees we have 360 degrees, but what about radians? Well, with radians, I'm just going to use the equation that I just set up. And the arc length, well, that's just going to be my path. But if I'm walking all the way around a circle, right? So if I'm walking all the way around a circle, that's just the circumference. And I know the circumference is just 2 pi r. And then I'm still dividing by the radius, but I can see that this nicely crosses out, and it just gives me that 1 full rotation is 2 pi. So I can see now that 2 pi radians and 360 degrees are equivalent, and pi radians and 180 degrees are equivalent.